Hello friends, welcome to our channel Laha Zindagi Edu-Care. Our channel provides online learning materials of maths and science from class 8 to class 12. Please visit our playlist section to get benefits of these free online learning materials. Okay friends, so today our topic of discussion is functions. Before starting this topic, I will advise you those who have not gone through sets and relation chapter, please go through those lectures of sets and relation so that you can easily understand this chapter. Okay, friends. So in functions, we will discuss function as a special kind of relation. Then we will see function as correspondence, description of a function, and we will see how to find domain, codomain, and range of the functions. Okay, friends. So, what is a function? See, Latin meaning of function is operation. Okay, it is derived from operation. So, we will discuss function as a special kind of relation. Okay. So if A and B are two non-empty sets, then a relation from A to B or a subset of A into B is called a function from A to B. So we can write if A and B are two non-empty sets, a relation F, we denote relation from A to B as F from A to B, that is a subset of A into B, is called a function or a mapping we also called it as mapping, is called as function or mapping or a map from A to B, from set A to set B, if the first condition is for each element of A, element of set A, there exists some element B which is an element of set B such that AB is an element of F. Okay. Second condition, AB is an element of F and AC is an element of F. It implies B must be equal to C. if AB is an element of F and AC is an element of F, then B must be equal to C. So a non-void subset of F is a function from A to B if each element of A appears in some ordered pair in F and no two ordered pair in F have the same first element. From 1 and 2, we can conclude that each element of A must have some image in set B, and for same element of A, set A, there cannot be two different elements in set B. Okay, friends? So if F or we will write if AB is an element of set F, then B is called the image of A under F. Okay. So if we consider example, if we have suppose two sets, let A is equal to 1, 2, 3 and B is equal to 2, 3, 4, 5. Okay. F1, F2, F3 be three subsets of A into B. So F1, F2, F3 are three subsets of A into B as given. F1 equal to 1, 2, 2, 3, 3, 4. Okay. F2 is given as 1, 2, 1, 3, 2, 3 and 3, 4. F3 is 1, 3, 2, 4. Okay. So if we see this, F1 is a function from A to B. Can we say that whether F1 is a function from A to B? So if we see the first element, so for each first element, there is an element in set B. Okay, if we see 1, it has element 2, then for 2, it has an image 3, 3 has an image 4. And for no two same element of set 1, set A, there are different images. Okay, so F1 is a function from A to B. Okay, if we see F2, then we can see F2 1, 2 and 3. So 1 is an element of A, but it has, see, 1 has two images in set B, 2 and 3. But as we know by definition of a function, no element of set A should have two images in set B. So F2 cannot be a function. So we can write F2 is not a function. Then if we see F3, F3 has 1 3 and second is 2 4. So if we see set A, 1 has some image in set B which is 3, 2 has an image in set B which is 4, but 3 does not have any image in set B. So we can say that, as we know by definition of function, for each element of set A, there exists some element in state B. Okay, so F3 is also not a function. Okay, friends. So next we will see another problem. Please write down x y if x y is an element of set 1, 2, 3, 4. Okay, then which of the following are functions in the given set? So we have to find whether the given relations are functions or not. First one is f1 equal to xy such that y equal to x plus 1. Second one is f2 equal to xy such that x plus y is greater than 4. Third one, f3 equal to xy such that y is less than x. And fourth, f4 is equal to xy such that x plus y equal to 5. Okay, and if all these are functions or any one of the functions, find a range in case of functions. Okay, so how we can solve this? So first we have to express f1, f2, f3 and f4 in terms of ordered pairs. Then we can see whether these are functions or not. So if we express, so f1 will be, see, xy such that y equal to x plus 1. So if we see xy is an element of 1, 2, 3, 4. So 1, then y will be 2. Okay. If we consider 2, y will be 3. If we consider 3, y will be 4. If we will consider 4, y will not be in that shape. So we will not consider that one. Okay. Because we will not get that image. Then f2 equal to xy such that x plus y is greater than 4. So if we consider 1, then to be greater than 4, it should be ordered with 4 only, because 1 plus 3 will give only 4 and 1 plus 4 will be greater than 4. So 1 4, then we may also have 4 1. Next, if we consider 2, So 2, 3, 3, 2 will be okay. Then 2, 4, next will be 4, 2. Okay. Then we will consider 3, 4, 3, 4. So 4, 3. Okay. So now we will define F3. F3 is x, y such that y is less than x. So if we have x1, so we will not have any y less than x. So we will not consider 1. If we consider 2, y will be 1. If we consider 3, y will be 1. If we consider 4, y can be 1. Okay. So next we will consider y as 2. So 3, 2 and 4, 2. Next we may consider y as 3. So 4, 3. So this is F3. Next one is F4. F4 is such that x plus y equal to 5. So if we consider 1, then 1 and 4 can be possible. Next one 2, 3. Another one maybe 3, 2. After that 4, 1. Okay. So there are 4 ordered pairs in F4. Now we will see first one, whether F1 is a function or not. See, if we see 1, 2, 2, 3 and 3, 4, but we observe that element 4 of the given set has not appeared in the first place in any of the ordered pair. So F1 is not a function for the given set. Okay, F1 is not a function as 4, which is an element of given set, is not in the ordered pairs. Is not in the first element of ordered pairs. First place we can write first place of ordered pairs. Okay, that is 4 has not any image. Second one, if we see F2, so if we see F2, we can see that 2, 3 and 2, 3, 4. Okay, so 2, 2. So 2 also, 3, then 3. So if we see the first element, for the same first element, we are getting more than one image in set B. Okay, that is 2, 2, 3, and for 2 also we have 4 as an image. Then for 3 we have one image as 2, another image as 4, and for 4 we have first image 1 and next image is 3. So as 2, 3, 4 have more than one image, so F2 is not a function. Okay, next we will see third one, F3. So first we will check whether all elements are covered in set A. 2 is covered, 3 is covered, 4 is covered, but 1 does not have any image. Even if we see 2, 3, 4, and 4 see, if we see 4, 4 has more than one image, 4 1, 4 2, and 4 3. So this is also not a function. Okay, f3 is not a function as 1 has no image and 3 and 4 3 and 4 has more than one image, more than one image. Okay, now we will see fourth one. 1 4 2 3 3 2 and 4 1. Next we will see for 1 we have only one. So we observe that each element of the given set has appeared as first component in 1 and only one ordered pair of F4. So F4 is a function as each element has image and no element has more than one image. Okay, so we can say that F1, F2, and F3 are not functions and only F4 is a function. Okay, friends, so let me clean this. Next, we will see function as correspondence. Okay, so if A and B are two non-empty sets, then a function from A to set A to set B is a rule or correspondence which associates each element of set A to elements of set B such that all elements of set A are associated to elements in set B and an element of set A is associated to a unique element in set B. So we can define function as a correspondence as let A and B be two non-empty sets, then a function f from set A, function f from set A to set B is a rule or correspondence or method which associates elements of set A to elements of set B. such that first all elements of set A are associated to elements in set B. Next one, an element of set A is associated to a unique element in set B. Associated to a unique in set B. Okay. So it is if a given relation is a function, if 1 and 2, these two conditions must be fulfilled. Okay. So a function from A to B associates each element of A to a unique element of set B. So we can write a function f from set A to set B associates each element of set A to a unique element of set B. Okay, and the terms mapping, correspondence are synonymous for function. If someone uses map or mapping, or someone uses correspondence, these are synonymous. These are synonymous for function. Okay, or we can write these are synonyms for function. So we can write f a to b, f of a to b, or a to b. Simply it is denoted a to b, and it is read as f is a function from a to b, or f maps a to b. F is a function from a to b, or f maps a to b. Okay, so an element of A associated to an element of set B, then B is called F image or image of the. So if A is an element of A and B is an element of set B, and function associates A to B. Okay, f of A to B. Then B is called as F image of A or image of A under F, or even it is called as value of the function at A. Function at A. Okay, so B is equal to F of A. So let me clean this. So we will take an example how it is shown as a correspondence. So if we have set A equal to 1, 2, 3, 4, and we have set B as A, B, C, D, E, and F1, F2, F3, and F4 are rules associating elements A to B, and we have to find whether the given rules defines a function or not. So F1 is given as, see, this is given as set A, this is your set A, and this is your set B. 1, 2, 3, 4. Okay, A, B, C, D, E. So it is a rule is given F1, and arrow are connected from 1 to D, 1 to D, 2 to B, 4 to C, 4 to C. Okay. So next rule F2, if it is your set A and this is your set B, rule is given as F2. It has element 1, 2, 3, 4, and this has A, B, C, D, E. So if we see that 1 is associated with A, 2 is associated with B, 3 is associated with C, 4 is associated with C and E. Okay. Next one is given as F3. So this is your set A, set B, and a function is defined, or we can tell a rule only. So 1, 2, 3, 4. This is A, B, C, D, E. So 1 is related to A, 2 with B, 3 with B, and 4 with E. Okay. Next rule is given as, this is set A and this is your set B. So it has, this rule is F4, and elements are 1, 2, 3, 4. A, B, C, D, E. 1 is linked with B, 2 with C, 3 with D, and 4 with E. So now we have to tell which of these F1, F2, F3 or F4 are functions. So if we see F1, so F1 is not a function. As we can see, 3 is not having any image in set B. Okay, 3 does not have any image in set B. So F1 is not a function. If we see F2, so if we see 1, 2, 3, 4, all are having images in set B, but 4 does not have a unique image. It has two images in set B, that is C and E. So F2 is also not a function. Next, if we see F3, all the elements of set A are having images in set B, and all the elements in set A are having unique images in set B. 2 and 3 both have image at B, but these have only one image in B. So F3 is a function. It is not a function we can write. F2 not a function. F3 is a function. And F4, if we see all the elements have unique images in set B, so F4 is also a function. Okay, friends. So let me clean this. So how we can describe a function? Description of a function. Okay. So f a to b is a function such that set A consists of finite number of elements. Then fx is described by listing the values which it attains at different points of the domain. Okay, so we can write let f a to b be a function such that set A consists of a finite number of elements. Then fx be described by listing the values which it attains, the values which it attains at different points of its domain. Okay, so what is a domain we will discuss. So if a function fz f of z such that z. Okay, z is a fraction, so it is given by z is given by integers. Okay, z is an integer given by fx equal to x square plus 1, or f of r to r. Okay, so for each r there is an element in r. Each real element, for each real element r, there is some image in set B. Okay, so it may be defined as given by fx equal to e to the power x. Okay, these are examples of infinite sets because it will have infinite number of elements in domain. If we talk about finite number, so let set A is equal to minus 1, 1, 2, 3, and set B is described as f of set B is given by elements f of minus 1 equal to 3, f of 1 equal to 0, f of 2 equal to 3 by 2, and f of 3 equal to 0. Okay, so set B will have 3, 0, 3 by 2. Okay, so this is a finite set and this has infinite set of elements. Next we will discuss domain, codomain and range. Domain, codomain and range of a function. Okay, so if we have a function from A to B, then what is domain? Set A is known as domain of F. Set A is known as domain of function F. Set B, so we will codomain. Set B is known as codomain of F. Okay, and what is range? The set of all images or element, so it is the set of all F images, we can write, of elements of A. Okay, so it is defined as range of F, or even we say image set of A under F, the range of F. So if we see f of A is equal to fx such that x is an element of A, and this is your range of F. Okay, so for all elements of X, fx will describe the range of f. And we can clearly see fa will be a subset of codomain, or we can say here b, or we can write range is a subset of codomain. Okay, a range is a subset of codomain. So let me clean this. So we will see a problem. Let set A is given as -2, -1, 0, 1, 2. Okay, and a relation fx is given as from A to Z. So f of A to Z is given by fx equal to x square minus 2x minus 3. Okay, so we have to find the range of f. First one, range of f. Okay, then we have to find second one, pre-images of pre-images of 6 minus, sorry, pre-images of 6 minus 3 and 5. Okay, so we have to find range of f, then pre-images of 6 minus 3 and 5. So we will start first one, as function is given as fx equal to x square minus 2x minus 3. So we will find the image of each element of set A. So f of minus 2 equal to minus 2 square minus 2 into minus 2 minus 3. So 4 plus 4, 8 minus 3, 5. F of minus 1, it will be minus 1 square minus 2 into minus 1 minus 3. It is equal to 1 plus 2, 3 minus 3 equal to 0. F of 0 will be equal to minus 3. Then next element is 1. So f of 1 will be 1 square minus 2 into 1 minus 3. So minus 4. And f of 2 is equal to 2 square minus 2 into 2 minus 3 equal to minus 3. So we can write range of f equal to f of minus 2, which is 5, then f of minus 1 is 0, f of 0 is minus 3, f of 1 is minus 4, and f of 2 again is minus 3, which will repeat, so we will ignore that. So range of f is this one. Second one, we have to find pre-images of 6 minus 3 and 5. So it is means fx is given or image is given, and we have to find the element of set A for which value is 6. So fx equal to 6. It implies x square minus 2x minus 3 equal to 6. So it is a quadratic equation. We can solve this. Okay. It will give your x equal to 1 plus minus root 10. Okay. Next is f of x equal to minus 3. So x square minus 2x minus 3 equal to minus 3, or x square minus 2x equal to 0. It will give x into x minus 2 equal to 0, or x equal to 0 or 2. Third one is f of x equal to 5. It will give x square minus 2x minus 3 equal to 5. So x square minus 2x minus 8 equal to 0. So after this we will get x minus 4 into x plus 2 equal to 0. It will give x equal to 4 or x equal to minus 2. Okay. Since minus 2 is an element of A, okay, see here it is minus 2, but 4 is not an element of A. So, and 4 is not an element of A. So pre-image of minus of 5 is minus 2. First one we can check, both are not elements. X equal to 1 plus minus root 10. So this is not an element of set A, so no pre-image. It will have no pre-image. And if we see for x minus 3, x equal to 0 and 2, so both are pre-image. Okay, both are acceptable. So let me clean this. Next we will see equal functions. Equal functions. So what are equal functions? Two functions, we can write two functions defined by f and g are equal if first condition domain of f equal to domain of f equal to domain of g. Second one, codomain of f equal to codomain of g. And third, fx equal to gx for every x belonging to their common domain. For every common domain, okay, domain of both will be same. So we can write if two functions are equal, then f equal to 0. Okay. So we will take a problem. Set A is given as, let a function f r minus 2 to r. Okay. Is defined by fx equal to x square minus 4 by x minus 2, and g r to r is defined by gx equal to x plus 2. So we have to check whether f equal to z or not. Okay. So we have to check whether these functions are equal or not. So how we can do this? See, as fx is given, so fx equal to x square minus 4 by x minus 2, and x is not equal to 2, so we can factorize this as x plus 2 into x minus 2 by x minus 2, so it is equal to x plus 2 for all x is not equal to 2, and gx is equal to x plus 2, so it implies fx equal to gx for all x, for all x not equal to 2. Okay, so fx equal to gx for all x which is an element of real numbers minus 2. But here if we see, fx has domain of fx equal to r minus 2, and domain of gx equal to r. So as domain are not equal, as domains are not equal, not same, therefore f is not equal to g. Okay friends, so today we have discussed function as a relation, then function as correspondence, then we have seen what is a codomain, domain and range. Also we have discussed equal functions. I hope all of you have understood. If you have any doubt, please let me know in the comment box. I will try to resolve your doubts. Okay, friends? And if you have seen the whole video and liked it, please like the video and subscribe our channel Ahajundgi Edu here. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay, friends? Thank you.